Subject name Compiler Design, Unit 5, 3rd year CS/BS Computer Science, 5th semester. Topic is Architecture Dependent Code Improvement. Architecture Dependent Code Improvement. Here we need to take care of optimization. That is, instruction scheduling is a compiler optimization used to improve instruction level parallelism. Instruction scheduling improves performance on machines with instruction pipelines. Pipeline is a technique where multiple instructions are overlapped during execution. Pipelines are connected with one another to form a pipe-like structure. And then instruction scheduling having several types: local scheduling, global scheduling, module scheduling, trace scheduling, and superblock scheduling. Hazards or affect code improvement. Pipeline hazards are situations that prevent the next instruction in the instruction stream from executing during its designated clock cycles. Any condition that causes a stall in the pipeline operations can be called a hazard. There are three types: structural hazards, data hazards, and control hazards. Structural hazards are also called resource hazards. In the structural hazards, when two or more instructions that are already in the pipeline need the same resources, now the result is that instruction must be executed in series rather than parallel. Data hazards, also called race hazards. In the data hazards, when one instruction is dependent on the results of the preceding instruction and that result has not yet been calculated. In this situation, the result is that instruction must be executed in series rather than parallel. There are four types of data dependencies in data hazards: read after write RAW, write after read WAR, write after write WAW, read after read RAR. Read after write data hazards, which is also called true dependency or flow dependency. The value produced by an instruction is recorded by the subsequent instruction. For example, add R1, subtract a new value R1. So otherwise we can say instruction 2 will read the old value instead of the new value. Write after read data hazards. This is called anti-dependency. These hazards occur when the output register of an instruction is used right after read by the previous instruction. For example, add a new value R1 and then subtract R1 new value. So also called instruction 1 must be come first, or it must be read the new value instead of the old value.